We are live. Got a couple hours now. Not even, got an hour and a half now. Do some little bit of research on some stuff. Yeah. So I want to look at the current sweep. Both of these really. It looks like this one crashed at some point. They both crash. I want to look at that. But in the meanwhile, oh no. There it is. There's the new one. So this was pretty good. In fact, I think we have a 3-minute solve. Let's see. But yeah, look at this. The Pareto front is very nice here. 3 minutes for solve. Now, there are a few questions I would have here. Why did this take? Oh, hey, how's it going? We're doing a little experiment analysis here. The first thing I want to know is why it took so long. Like, what are the optimal parameters and why were they so hard to discover? Are they weird? And was there something to this? So we'll go by a sample first. Whoops. What? Where is my dashboard? Okay, there we are. So, learning rate. Learning rate gives you stable perf pretty much anywhere in this region. Entropy, same thing. Same thing. A lot of these, honestly, these parameters are very stable. In isolation, at least, they look like they're very stable. Heck, I mean, we have solves on all of these different ones, right? So what was it that took so long to discover? It looks like you can solve it with basically any of these parameters being anywhere. So a specific combination. If we look at here, maybe we can add a filter here. So we can do score, $8.40. I don't understand their query system and how to get it to work. There it goes. Okay, so we can see lots and lots of parameters fill these criteria. And then if we take this one, we add an additional filter. Let's do time. Less than 240. Then we do filters. Okay. Or as it was a cost. Okay. So we have a lot of these runs. Very small batch size. No, medium batch size. Mostly 50 million time steps. Varying number of M's. I guess what we'll do is create some filters. All right, so here are all of the really good runs. And look at this. Lambda is very precise for these runs. Very precise lambda. And gamma, there's a little flex, not a ton. Max grad norm has some flex in it, quite a bit of flex. VF coefficient has quite a bit of flex. Surprisingly, there's a bit of flex in update epochs, as well as the horizon. Num is very low. In fact, we should be able to even go lower here. Kind of odd. Batch size, 64K, that's reasonable. Total time steps, about 50 million. It looks like we can potentially go lower than this as well. Because if we go to the charts, let's see. There's a little bit of flex in here. Right, some of these are done kind of early. I think there's still some room for improvement. So why did this take so long to find these parameters then? Model randomly start with values. It uses the center point at the moment of the search space as its first trial. There are some random seeds at the moment at the start as well, which I would prefer not to have to need. So we're going to see how that goes. The current default parameters for breakout are really not good though. Well, we can just cut off a lot of this by just cutting the total time steps to something more reasonable. I do want to see those. So if we look at this, we progress. It's this one. Sweet progress. They're mostly towards the end. It's actually pretty much all of the runs towards the end, isn't it? Yeah, so all the runs towards the end. So where is the essential? Let's see. Let's just go down these parameters one at a time. So batch size, 60K and 130K are both fine. Whoops. It's there from the start. Total time steps is lowered, but that's not going to hurt perf. It goes up and then it goes back down. Well, that's really interesting, actually. Look at this. It goes up and then it goes way back down. Kind of an interesting property. So I think this is where it wastes a lot of experiments. We will have to think on this. Can I question you? Can I question from you? Of course, hello. Yeah, you can ask questions, sure. Give it time and emojis will load. Yeah, the emojis don't load instantly, as you can see here. I also have to review the other paper. I'm just going to do this real quick, and then hopefully I can review that paper right after. Learning rate. So anything 02 to 08 is kind of fine. It doesn't seem particularly bothered. So yeah, it had that from the start. Gamma 9.5, Yeah, that's available from the start. Lambda 6, available from the start. Update epochs. Let me see. At least 2 update epochs. A couple samples from the start, but then I got stuck on one for a while. And I don't know why. What's your project? It looked like Unity with AI. I generally, this is research. My goal here is to just make reinforcement learning faster, simpler to get working on new problems in a ton of different domains. And we build really good tools around doing that. At the moment, what I'm doing is I'm working on a hyperparameter sweep algorithm, which will make it easier to automatically tune an algorithm to every new problem that you throw it at. Each of these points is an experiment where an agent has been trained to play breakout. The thing that's important here is not breakout, it's the qualitative behavior of this algorithm. PPT horizon is available from the start, right? Oh, interestingly, it likes 32, but we do have some samples at the start as well. Num_ems is low, okay? That's discovered pretty quick, though. And then the Pareto front. Mini batch is very robust. Okay, so maybe update epochs and time steps. These two graphs tell a story. So it's difficult to even be mad here. This is so reasonable. Like, it uses additional compute to solve the problem. And you can see it maxes total time steps for a bit. And then it does it more efficiently over time. And then eventually it kind of figures it out. Wrong one. Actually, we will do something here. Auto on everything. Okay. I think this is reasonable. What's the token cache thing? So we can kill this. Runs are ridiculously good. I'm curious to see if this is even faster, this sweep. Okay, so we'll let that be for a bit. And then we need to look at the other experiments real quick, the other environment. I think these take quite a while. Well, I can literally just rerun the same thing without E3B, and that'll be a decent enough comparison, right? Heh, something broke. That's weird. Not the driver, though. Cool, so we have the experiment set up. Yeah, and then I think we will be able to check these back after dinner. I do have a paper to review. I have to do that off stream, though. Oh, perfect. So this is going to be 160 cost. Great. These should be pretty quick to run then. Yeah, this will be nice. Why is the first one at 100 million? Weird. That's fine. Hopefully this does something different. We shall see. But I do actually want to make sure real quick that we actually got the thing that we wanted to, because that is a little suspicious. Oh, this didn't pull? What? Good cow. Rams. Good catch. That would have been a waste. When you do paper reviews that are not typically, I don't review papers outside of my fields. And that would be a stupid thing to do, right? I mean, I'm better qualified than the average person by far to read papers outside my field. I read papers that are in RL or ML, but outside of my direct area of experience, sure. Cool. I can really, yeah. And I no longer really care about the formality and the formatting because I'm no longer in the business of academia. I'm in the business of making RL work, right? But I do have to go review this thing, and this does have to be off stream, so I will go do that. And then I'm going to get some dinner, and then I will be back after dinner, most likely. Probably checking on some experiments, unless I can't think of anything else to do work-wise here. We'll see. I might just go to bed early. But yeah, these experiments should be good. We're getting very, very close to having something here. It's going to just take some more experiments and some more fiddling, but this should end up quite well. So, see you all around.